Good afternoon to all. We would like to introduce our next resource person, Dr. Jyotsna Kumar Mandal, Department of Computer Science and Engineering, Kalyani University, former VC, Raiganj University. Dr. Jyotsna Kumar Mandal, MTech in Computer Science from University of Calcutta in 1987. Awarded PhD Engineering in Computer Science and Engineering by Jadavpur University in 2000. Working as Professor of Computer Science and Engineering, University of Kalyani. Former Vice Chancellor, Raiganj University, West Bengal. Former Dean, Faculty of Engineering, Technology and Management, KU, for 2 consecutive terms during 2008 to 2012. Former Director, IQAC and Chairman, CIRM, Kalyani University. Served as Professor Computer Application, Kalyani Government Engineering College for 2 years. He was Associate Professor Computer Science for 8 years at North Bengal University and Assistant Professor Computer Science, North Bengal University for 7 years. He also served as lecturer at Northeastern Regional Institute of Science and Technology, Itanagar for 1 year. 36 years of teaching and research experience in coding theory, data and network security and authentication, remote sensing and GIS-based application, data compression, error correction, visual cryptography and steganography. Awarded 30 PhD degrees and 8 are pursuing. Supervised 3 MPhil, more than 80 MTech and more than 130 MCA dissertations. Guest editor of MST Journal, SCI Index of Springer. Published more than 450 research articles, out of which 200 articles in international journals. Published 12 books from Springer, LAP, Germany, IGI Global, etc. Recently, he has published a textbook on reversible steganography and authentication via transform coding from Springer. This book has been translated into Chinese language and republished from China by the Springer. Organized more than 60 international conferences and proceedings. Editor of edited volumes and conference publication of Springer, IEEE and Elsevier, etc. and edited 60 volumes as volume editor. He has completed 5 research projects from which grants received from AICTE and Government of West Bengal. He served as Secretary and Chairman IETE Kolkata Center, Governing Council member of IETE, Chairman CSI Kolkata Chapter and CSI Shiliguri Chapter. Peer team member of NAC accreditation process, expert member of AICTE EVC, conduct academic audit of various universities and institute, member of ISO IEC JTC 1 SC 36 WG8, learning analytics interoperability, member of Bureau of Indian Standard, LITD 17, 19 and 36. Higher Education Department, Government of West Bengal, India, conferred Shiksha Ratna Award for Outstanding Performance in Education in 2018. ISO Annual Meeting 2023 hosted by Standard Australia in hybrid mode from 18 September 2023 to 22 September 2023. In the plenary meeting of SC36, he have been selected and declared as convener of working group ISO JTC 1 SC36 WG7, nominated from BIS India. SC36 WG7 ITLET, Culture, Language and Individual Needs, under ISO IEC JTC 1 SC 36, next 3 years from January 1, 2024. Highest number of 203 Scopus-based journals publication in last 10 years among all faculty members of the University of Kalyani during 2013 to 2022. 4 SCI, SSCI publication till date in 2023 with 2 publication of impact factor more than 5. Highest impact factor 6. Total impact factor of this publication is 15.677. Few are in pipeline. Impact factor of 5 based publication is 21.577 with the highest impact factor 8.5. Out of them 2 are of impact factor more than 7. Impact factor of 10 best publication is 41.577 with highest impact factor 8.5. Out of them 4 are of impact factor more than 5. 2 more scholars awarded PhD degree under his solo supervision in 2023. In total, 30 scholars are awarded PhD degree under his supervision. In all cases, Dr. Mandal is the principal supervisor and 5 more scholars are registered under his supervision in 2023. Total SCI, SSCI publication in last 6 years is 41. Designed and implemented full campus networking consisting of 4-kilometer fiber optic network along with UTP network at the University of North Bengal during 1998 to 2000 from the project fund received from UGC, that is of 80 lakhs. Took active participation to open Department of Engineering and Technological Studies under Engineering faculty and 2 streams of undergraduate studies, Information Technology and Electronics and Instrumentation Engineering as Dean Faculty Member of Engineering, Technology and Management and University of Kalyani in 2008. Actively involved in infrastructure development, networking, wireless communication between main campus and hostels situated at a distance of 2 km from the main campus of Kalyani Government Engineering College as coordinator of TEQIP 1 in Kalyani Government Engineering College, Government of West Bengal during 2006 to 2007. Domain expert of Uttarbanga Krishi Vishwavidyalaya nominated by ICAR Government of India for planning, designing and implementation of networking and internetworking of Uttarbanga Krishi Vishwavidyalaya campus, Kuch Bihar. During his tenure as head, Department of Computer Science and Application, University of North Bengal during 2002 to 2004. Domain expert member of West Bengal University of Animal and Husbandry, Belgachia, Kolkata for designing and implementation of video conferencing lab at Belgachia campus and Horinghata campus, West Bengal during 2009 to 10. He will now discuss about authentic learning, automated comprehensive e-assessment and grading. We now hand over the session to Dr. Jyotsna Kumar Mandal. Please, sir.
Thank you for elaborate introduction.
Welcome,
So
sir.
my agenda is introduction. The objective of first 2 segment of my lecture is there. So out of 2 segment, my first segment is on mostly confidence-based learning. So second segment will be assessment and grading. So in the first section, we have the concept of confidence-based learning systems. Nowadays, you see all of us very much aware of e-learning system, and these e-learning systems, how it is going on. You see that I am extending some material to some web portal. Some materials are available as course material, as a video lecture, and we are disseminating the material in terms of registration or in terms of some access of the material, and followed by some examinations, and we are giving the certificate. Now, what is the outcome of this learning session? So can it be judged? I know that I have taken a material and I have given the examination, I have got the certificate. Now, what is my confidence level? What is the outcome? So outcome based learning is main motto of this lecture. So your learning may be possible in synchronous and asynchronous mode, and mostly of the skill gap analysis and to mitigate the skill gap. Now, when we are talking about technology enabled learning or authentic learning, this learning addresses three different issues. One is in your cognitive domain, second one is your adaptive, and third one is psychomotor. So we are dealing with the cognitive domain of learning. So in cognitive domain, we have knowledge, comprehension, application, analysis, synthesis, and evaluation. And the learning approach, whatever we are talking, there are two learning approach. One is called the surface learning and other one is called the deep learning. So out of these phases, you see that knowledge and comprehension of a learner is categorized as surface learning, and rest of the things, application, analysis, synthesis, and evaluation, these are called the deep learning. So this is not the neural network based conventional deep learning. This is learning methodology in terms of Bloom's taxonomy. And this confidence based learning has been initiated by Darwin, Hunt, Leclerc, Safford, Bruno, etc. Where only knowledge is not the parameter or the thinking parameter. Along with that, the confidence is also to be, and the judge also to be judged. In that case, what we need? We need a two-dimensional assessment system. What is the two-dimensional assessment system? That means assessment is there not to give a certificate. Assessment is there to give a learning material. How much confidence you have grown on a particular subject prior to disseminating the material, we are judging the confidence level, and based on the judgment of the confidence level, the materials are disseminated. That is, we are customizing the learning content that is not available in normal e-learning system. So, if we think of confidence-based learning or CBL, so you see it has been designed in three phases. What are these three phases? One is called the diagnose, second one is prescribe, third one is learning. Now, what is the meaning of diagnose? That means I am diagnosing your capability and the confidence. And based on your level of confidence, it may be misconception, it may be, you see, that surface learning or deep learning. So we are prescribing the learning material and you are learning. So this is called the confidence-based learning. So now when I'm talking about the diagnosis phase, this diagnosis phase consisting of confidence-based assessment and diagnosis of the deficiency. That means I'm diagnosing the deficiency of a learner, particular learner. That means suppose on a subject C++, I have two learners. So one learner is weak in variable and other learner is weak in loop. So I will give the material variable based on the variable to learner 1 and I'll give the material based on loop to second learner. But before that, I have to judge or diagnosis is to be done. What is the deficiency of a learner? And based on that, your prescribed phase is providing the customized learning plan. So the learning phase is always help for the learning. So now what will be the structure of this type of confidence-based learning systems? Where we can give the learning content dynamically. So I need a robust assessment mechanism prior to disseminating the learning content. So deficiency diagnosis technique is a major task in real world assignment or in authentic learning system. And based on that, we are prescribing the content. We are prescribing the content. I think sharing has gone.
Yes, sir.
Sharing has gone. Are you see the sharing?
No, sir.
Yeah, I'm just doing that. Yeah, now it has come.
Yes, sir.
Yeah, just. Yeah, now it is visible, no?
Yes, sir. It is now visible.
I don't know why it has gone. So now we need a comprehensive structure of content that can be given dynamically. And we are monitoring the mechanism of learners' confidence at all phases. And we are mapping the content for authentic learning. So this is the framework. What is the problem definitions? That is, first we need a two-dimensional assessment systems, which is absent in conventional learning or conventional confidence-based learning. And measurement of precise knowledge and confidence factor is an important, plays an important role. And you have to identify the deficiency of a learner, both in the classroom environment and from the world of work. And we are giving the customized learning content. What is the challenge? The delivery of automated customized learning plan. So everything is automated. We are not doing anything in manual manner. So what is the proposal? The proposal is that you have to design and develop automated learning object from the material of the course. And how we can go for it? First, you go for 2D assessment technique for a typical learner. assessment of the learner from day-to-day activities or world of work. How we can do it? Using learning record store, which is called the LRS. I'm coming to that. Then we are presenting the content or giving the content, and we are designing the granularity of the content by decomposing this instructional object or learning material in terms of academic competencies. And we have to define the interdependencies of the academic competencies and interdependencies of the task. And it will go for an iterative level. So as a result, we are incorporating the authentic learning within the CBL. So you can see here that this is the structure. That in this structure we have the two-dimensional assessment system on the top. This is the proposed model. We have the confidence-based assessment. Then we are diagnosing the deficiency, and based on that deficiency, we are prescribing the learning content to the learner. Learner is learning, updating the knowledge, and we are going for a structure of the learning object based on that we are disseminating. And then dependency structure matrix of the material is to be analyzed, and granularity of the material is to be designed properly. So now about the learning object. What is the learning object? The chunk of material or learning contains is called the learning object. It is developed using conventional tools and technique, which is insufficient. Because I don't know where is the lacuna of a learner. We never assess that. We only prescribe some material based on a course on my website or some system, and then we are disseminating, we are taking an examination, and we are giving the certificate. So that is not sufficient in terms of confidence-based learning and authentic learning. So the subject matter analysis are performed and content-based instructional objectives are required for this designing of the learning object. So what is the scheme? The scheme is to divide the complete task into the multiple tasks T1, T2, T3, T4, like that. And then you go for dependency analysis of the task T1, T2, T3, Tn. How? The tasks may be independent. All tasks may be dependent to another task. Some task may be dependent to other task. One task may be dependent to multiple tasks. Some task may be dependent as a multi-level dependency. So now we are thinking of two types of tasks. One is called overlapping task, non-overlapping task. Another one is overlapping task. So you see, at the beginning, I was talking about the non-overlapping task. That means all tasks are not overlapped here. And we are analyzing the dependency among that task. Then we are also going to analyze the dependency of the overlapping task. There may be partial overlapping task. There may be partial overlapping tasks that are dependent on other tasks. There may be partial overlapping tasks with multi-level dependency. You see, these are the non-overlapping tasks and their dependency. You see on the first leftmost top picture is no dependency. In the second, there is a dependency on some task. Now, we have a multiple dependency task, then we have multi-level dependency. So these are all non-overlapping tasks. Now, if you go to the next slide, here you see that all tasks are overlapped. But you see in the first slide, we have a dependency, not non-dependency. No dependent. T1, T2, T3, T4, T5, whatever may be. But others, we have dependency. It may be single level, it may be multiple level, it may be multi-stage, multi-level dependency. So, if we go for a mathematical model, what will be? That when I am designing a learning object or instructional object, which is based on particular learner, which is based on a typical learner K. And for that learner, we are designing the customized object. And this instructional object is divided into tasks T1 to Tn. So, what is the method? The method is that for a typical learner K, first we chose the MCQ randomly. This is not the assessment. This is to assess the prerequisite of the learner. This MCQ will be used for identification of the deficiencies, and each MCQs are mapped into the task T1. So we are talking about only the MCQ. We'll come to that. What is the consequence of that only MCQ? And we are judging the confidence level of the learner. And we are describing the learning object. So based on this, we have devised a mathematical model for that, for a learner K. This is the equation. I'm not going into detail. So here, there may be some input, some output, and some intermediate output. So what will be there? Individual questions or item, set of questions, item bank. These are all inputs. Output is the average level of confidence of a learner. And individual tasks are the input, and the set of tasks associated with IO is also input, and some intermediate outputs are also there. So let us consider a novel framework. We have to analyze whether the learner is required to have a deep or surface learning, whether the learner is required to go through superficial learning or detailed learning, whether the learner is improving trend or diminishing trend. What is the trend of the learner? Improving trend. So this cannot be done in the normal way. And how we are designing and developing the learning object? In terms of concept, in terms of terminologies, in terms of taxonomies, in terms of extra knowledge, reference, example, illustration, prerequisite, assessment, like this. Let's see the schematic diagram here. You see, for the prerequisite, we are giving media, object, text, audio. For the concept and terminology, taxonomies, we are giving the media object. For the external references, also media object, like that. Let us go for a case study of a learner. That the performance analysis of an individual learner X. Let us consider that we are giving the 20 number of MCQs in a question set from the item bank, associate with a level in the knowledge pyramid 1 to 6. I have shown you that knowledge pyramid. That means the randomly chosen questions from among all ranges are given. Suppose we are going for 4 tasks only. Let us consider. And we are analyzing the performance of the learner. So, you see in the first iteration, T1 is doubt, T2 is doubt, T3 is doubt, and T4 is ignorant. And based on that, you see learning analytics, we have surface analysis, deep learning, surface learning, deep learning, and we are giving the content. Based on that, add concept, terminologies, taxonomies, add concept, extra knowledge, reference, something like that. This is the first iteration. Let's go to the next iteration. That we have doubt, mastery, doubt, and ignorant in 4 tasks. You see that in task T2, the learner achieved the mastery. So no learning content is required. That means T2 is over. He has got the mastery. That means I'm just taking a threshold of the examination and I'm not prescribing the content for the T2. But I have to give the content for T1, T3 and T4. So let's do the next iteration. Here also again T1 is doubt. T2 as it has been mastery, so it will remain on that state. Then doubt, again T3, T4 is also doubt. And go to the fourth iteration. Now in fourth iteration, the learner has got mastery in T1. So no learning content will be given for T1 and T2. So learning content for T3 and T4. So T3 is in surface learning and T4 is in deep learning need. And we are giving the content accordingly. So let's go to the fifth iteration. So in fifth iteration, you see that all tasks T1, T2, T3 and T4 have got the mastery. That means no learning content is required for all the tasks. He has got the mastery. You see, in our normal or conventional assessment system, what we prescribe, you see, I am giving 7 questions, you have to answer 5 questions. In the out way, we are rejecting for 2 questions as an option. So he may or may not answer, may not have the knowledge on that 2 questions. That means I cannot say that the learner have got the mastery for all chapters. So that is the lacuna for normal e-learning systems, where the lagging, where the deficiencies on a particular subject, all world of work, or how can we map this authentic learning to the entire course of the subject or the material that is judged in confidence-based learning. So these are the performance whatever we have discussed earlier. And you see that learning effort from or task T1 to T4. So somewhere it is surface learning, somewhere it is deep learning, and based on that we are disseminating the material. So I think these are some of the this still I'm not going. So now when I am talking about the assessment, we are talking about the MCQ based assessment. So there is a deficiency in normal MCQ based assessment for a typical learner, because all quadrant of knowledge where it is staying I cannot understand, because you see I am marking option D out of ABCD and D is the correct answer. I may tick the answer knowingly, fully knowing, or half knowing, or with confusion, or with guess. So that is not possible to judge in this normal MCQ based test. So if we think of that learning confidence, the confidence of the learning we have defined in 4 stages: misinformed, uninformed, doubt, which is called the hesitation, and it is mastery. So based on that, we have to define my MCQ and the question, how we can go for it. So we can achieve that in terms of the 2D assessment technique. So how 2D assessment? We can go for it. You see, 2D assessment technique, you see that I have a stem of question. One is answer, others are destructor. And I am also taking the confidence level, whether full or partial. Then I am going for partial confidence level in multiple ways. That means I can give some weight of that and I can judge that what is the confidence level of a learner, and based on that I shall prescribe the material for that particular learner. So you see that again we are going for an individual set of questions, item bank, level of confidence we are getting as intermediate, and status is the output, that whether it is misconception or it is mastery, or you see uninformed or misinformed, like this. So now, what is the inadequacy of this 2D assessment technique? Though we are going for partial confidence or multi-level confidence or weighted confidence level, what is the lacuna? The lacuna is that, you see, I have gone for 4-5 iteration for that typical case study. So out of these 5 iterations, only I am terminating with the condition that the learner has got the mastery. I could not trace from where it has been reached to mastery. Was it diminishing trained and then gone to mastery? Or additive strength is increased and then it has gone to mastery? That means, you see, no record source is available. No history file is available. No history how the learner approached to the mastery. That is not possible in this 2D assessment section. Again, the screen sharing has gone.
Yes, sir. Same,
So,
sir.
this is the inadequacy in 2D assessment system. Because the assessment is normally done in a typical classroom environment. So, to identify the real lacuna, a feedback mechanism is required. What was, and what is. That means a tracing path is needed for the confidence-based learning. So for that, there is a need of learning record store. So a learner may perform well in day-to-day activity rather than performing in the evaluation phase. So that has to be kept as a LRS in the LRS. And this LRS will be the aggregated storage. And based on that, we can diagnose the deficiency and what was the history in 5 stages or 6 stages, that I can map, and based on that we can go for the evaluation of a learner using the LRS. So the LRS component is adopted to ascertain the performance of the learner, which can be identified beyond the classroom and conventional learning. So nowhere in our e-learning system it has been adopted till now. This is a complete research area, and I think even I also thinking of going for standardization of this type of things. So in order to identify the real lacunas, the feedback mechanism from the world of work and job is very much required. And you see, this is the framework of diagnosis of deficiency based on the LRS. These automated systems, AIMLs are using XAPI, tin can statements generations, all things are using. We are using here the metadata, and we are keeping track of the learner's action. Here manager, learner, you see all the feedback systems, all systems are automated, and the performance record, local performance record is also kept. So I can change my structure of confidence-based assessment, then identification of the critical gap, and deficiency diagnosis is done based on LRS, learning record source. So these are some of the things I'm just. Now, when I am talking about the deficiency diagnosis in terms of LRS, we need to analyze the dependency structure, because he has a lacuna of chapter X or task X. How it depend on the task Y. So a dependency structure analysis is done and a matrix is obtained. And you see that when I am prescribing materials, task 1, task 2, task 3, task 4, that may be all in a same level. Academic competencies are same or the identical. But during the course of learning and assessment based on LRS, the dependency structure will be different. The dynamics will be non-linear. Some task, the confidence level of the some task may be better. The confidence level of some other task may be less. So that can be defined in a non-linear data structure like tree. And you see, this is an example of how we can execute the algorithm. How we can execute? Suppose I have 5 tasks or 10 tasks, so all are in the same level at the beginning. Now on the first iteration, task T1 come to the upper level, T2 is middle level. So how do you define upper level, middle level, level X, level Y, level 2, level 3, level 4? For that, dependency and structure, we are going for a Hoffman tree based algorithm. Suppose you can use some other tree structure. So I am defining various tasks. I am defining the academic competencies, and with the probabilistic view, it is there. Now, based on the confidence level, attainment of the confidence level, so this tree structure will be a multiple one, you see. So, some may be at the leaf, some may be at the root. So, I can define that if it is at the root and if it is beyond a threshold, suppose 2.5, you have taken as threshold is 2.5 out of 5, it is mastery. So, if it is mastery, this task will go off from the tree. Then others again will go. Next level things will go the root automatically based on the performance of the learner. So that means a dynamic Hopman tree as defined by the Knuth in 1985. The dependency structure and the confidence level can be defined dynamically so that a learner can get the mastery of all given tasks with number of iterations. So all of this, whatever we are going for, the development of knowledge and skill component in the world of work, if we map with this technology, so we can incorporate our authentic learning. So development of knowledge and skill component is under the category authentic learning. Because you see, when I am going for a particular job and when I am trying to uplift myself from a stage or level to the next higher level, in that case, you see that this authentic learning is very important. So authentic learning and CBL must be well connected. Now another thing is that when I am mapping to the world of work or real world problem, that means I am mapping to the authentic learning. And same confidence-based mapping, same LRS-based outcome and LO design and dissemination of the LO is to be given. Now you may say that we are defining the task randomly. We are generating the level, all the level, maybe deep learning or surface learning randomly. How random it is? So nowadays, we are defining the dependency structure in terms of quadrant, and for the randomness, we are going for a non-linear dynamics. That means we are using the chaotic theory. What is the chaotic equation? Normally, the chaotic equation is a non-linear dynamics where both the right hand side and the left hand side are the same variable. That means you have to start with a predefined parameter, which is called the system parameter. Another problem is that you see that all the chaotic equations, normally it generates the real number, not the binary number. So my function will be a two-step function. That means first step we shall generate the real number, and in the second step we will fabricate or generate the binary random number. And when we are generating the binary random number, so can we say that this nonlinear dynamics is always unbiased? The second fold testing is also done. What are the second level testing? Second level testing is done in terms of some parametric test. What are the parametric test? The parametric test is called the monobit test, serial test, and the poker test. That means you see, when I am talking about 10 binary number, So what will be actual random number? 10101010, something like that. But suppose you are getting 51 followed by 50. So 50% of the number is 1 and 50% of the number is 0. So that is also random number. But that is absolutely biased random number. That is why these three tests are performed. If your generated, first you see that you are generating real number. Suppose I need 1000 binary numbers. So 1000 real numbers are generated. Then from there we are fabricating the binary number based on some conceptual framework. Maybe for the median, maybe out of that median, less than median is 0, more than median is 1. If I go for average value, less than average is 0 and more than average is 1, something like that, we can go for it. So out of this two-step generation, first step is your real number generation, second step is binary number generation, and after that we go for three tests: monobit test, serial test, and poker test. So if all three tests are passed, then I can say that my generated random number is perfect. And based on that, we are mapping the content, mapping the level in your cognitive domain. And we are mapping into the surface learning and into the deep learning based on the outcome of a learner in terms of the test. And based on that, we are disseminating the material. Yeah, like that. So it's called the allocation register, where we are mapping the task in terms of the binary random number. So if we think that augmented confidence-based learning is that we have a 2D assessment technique. We have the confidence-based assessment deficiency diagnosis in your diagnose phase. Then you are prescribing the content in prescribed phase, and the learner is learning and updating his knowledge for all the task, not a particular task or not some selected task. It may be for any task. And we are designing the structure of the LO. We are defining the dependency structure matrix or DSM and atomic competencies. And the outcome of a particular stage, is kept on the LRS. And if it is in the next stage, we shall compare with the previous stage, whether it is augmented to the positive directions or it is diminishing towards the negative directions. That means I can prescribe some other materials based on that trained analysis, whether it is a positive trained or it is a negative trained, like that. So based on that, when the learner reaches to the maturity level, that means mastery for all tasks, then only it will come out from the loop. Otherwise, it will be there and it will just go on doing that. And that is called the part of the authentic learning system. So what was the achievement here? You see, the new structure of learning objects is created dynamically in terms of various subcomponents. And a 2D novel assessment techniques we are designing in terms of confidence level. And we are integrating the learning record store within a diagnosis phase Based on that, we can analyze the trend whether the learner is achieving towards the positive direction or towards the negative directions. Again, we are designing the decomposition of the task into the academic competencies and the dependency structure matrix we are designing, and we are defining the nonlinear techniques for the diagnosis using chaotic functions, and we are mapping this to the authentic learning. So for the authentic learning, so I am coming to the next part of my talk, that is assessment. So the conclusion is that the objective is to propose a model for ACVL, augmented confidence-based learning and authentic learning. So various lacunas are there. These are very nascent stage. Even ISO is going for standardize this interoperability of the learning analytics. They are still in the nascent stage also. So this is my first part. These are the some of the publications from our scholars using this authentic learnings and other. This is one part, and we are starting the next part. Now, assessment for authentic learning. You see that in the confidence-based learning, we are prescribing the content based on the diagnosis of the deficiency. And based on that, when the candidate or the learner reaches to the mastery level, we are coming out to the situation. So there is no provision for the comprehensive assessment or other assessment. We are assessing to impart the learning material. That means to fulfill the learning objective. So the learner has learned everything, particularly from the world of work or in terms of the authentic learning. We need to know all these things so that I can serve my company as a whole, for the complete package, not for particular section or chapters. So no. When we are going for the technology enabled learning and assessment, here we are talking about the assessment. What is the definition of the assessment? It's called the act of assessing someone or something based on some critical criteria in teaching and learning system. So assessment can be used to improve the performance of a learner by defining, selecting, designing, collecting and analyzing or interpreting using information technology, which is called the scope of learning. Now assessment in education is called the evaluate, measure and providing the document, collecting the document and analyzing. So some synonyms of evaluation are, you see, evaluation, judgment, appraisal, rating, gauging, analysis, estimation, reckoning, valuation, determination. These are some synonyms. Now, assessment for authentic learning. It is the second stage. In this method, the conventional of the test and checklist are less relevant. Because you see, in conventional test, what we are doing, we are giving, suppose 10 questions or 7 questions. The candidate is answering 5 questions out of the 7 questions. And I don't know whether the knowledge is surface or deep, whether the knowledge is consisting of all task or not. There may be a good knowledge in the task A, there may be a bad knowledge in task Y. So we need to some methodology, have some methodology. Definitely the precursor of the assessment of the authentic learning is confidence-based learning or CBL. So normally, see, we have already discussed that it may be the surface learning and deep learning, and this slide already I have shown you that you have the cognitive domain of learning where we are dividing the learning in surface and deep learning. So assessment should be performed based on two different learning approach. That means based on the deep learning and surface learning. Now, what are the type of assessment? Pre-assessment or diagnostic assessment, formative assessment, summative assessment, confirmative assessment, norm reference assessment, criteria reference assessment, eFDP assessment. So, a lot of various types of assessments are there. So, we are only going to discuss formative and summative assessments. So, what is pre-assessment or diagnostic assessment? We have already discussed in details. So before creating the instruction or instructional object, it is necessary to know for what kind of students you are creating the instructions, and your goal is to get to know your students and level of your students, weakness of the students. We have already discussed it. And the formative assessment. The formative assessment is used in the first attempt of developing the instruction. The goal is to monitor the students' learning, to provide the feedback. So in summative assessment is aimed for assessing the extent to which the most important outcome of a learner has got. We have some other assessment. When confirmative assessment, when your instruction has been implemented in your classroom, it will necessarily take some assessment. So that is your confirmative assessment. We have norm reference assessment. Is the student's performance against the average norm. That you have to get 5 point minimum CGPA to pass. That is a normative reference. And we have some criteria based reference on the assessment which measure the student's performance against a fixed set of predefined rules. And in eFDP assessment is measure the performance of a student against previous performance. So mostly we are discussing the formative and summative. So formative assessment include the method that used in the classroom for evaluation of the students' comprehension level, which is an important tool called the skill development and skill set analysis, and which encourage the students to build their strength and overcome the deficiencies. So your formative assessment should be continuous in nature. And that is why your educator and experts believe that formative assessment is an integral part of your effective teaching. And summative assessment is used to evaluate or assess the students in terms of academic achievement at the end of a defined instructional period, which is called a semester nowadays. This is the end of course or semester or year. Mostly we are using the semester nowadays. And methods are evaluate rather than diagnostic. Only to evaluate. We never go for how much a student has learned, how he has answered, and we are evaluating the answer. We are not evaluating the knowledge of the student. We are evaluating the answer, whatever written by the student. That means comprehension level of a code is not considered any parameter. Whatever answer he has given, suppose I have 5 questions, 10 questions, and I require to answer 7 questions. All 7 has been answered. And he has got a 95% percentile. But suppose out of 3 which did not answer, he does not know anything about that. He has left that chapter. So this assessment does not confirm that. So the effectiveness of the course of a program is questionable. So what are the methods of summative assessment? The method of summative assessment may be questionnaires, surveys, interviews, observations, project, end semester program, testing, lot of things are there. So now come to the authentic learning assessment. So assessment of authentic learning is the measurement of intellectual and accomplishment which is needed for that particular learning. So it is devised by the teacher or in collaboration with the students, engaging the students' voice. So performance of the skill or demonstration of the skill using some methodology. So now this assessment, most of the cases we are doing manually. So assessment may be manual or automated. So we are thinking of the automated assessment techniques. That means it may be objective type, it may be short descriptive type. So we are not thinking of short MCQ type of answer. We are thinking of the comprehensive type of answer. So manual assessment is one of the most time-tested system still now, and it's done both for objective and descriptive. It is well suited for assessment of skill set. Now in automated assessment involves the evaluation of a learner in some form of electronic media examination evaluation system, which will be automated, and it will be normally NLP based systems. So let us come to the MCQ. So we are not talking about what the MCQ, that means I am giving a question, 4 options, 1 option is correct. So we are judging that only. So we are not interested on that. So we are, instead of that, let us consider a single sentence answer. So you have some model question, we have some questions, you have some answer, and you have a given answer by the candidate. So your model answer may be aggregated one. So you will compare the model answer with the given answer and will compute the similarities. How we compute the similarities? We compute the similarities in terms of bag of words, in terms of verbs. I can use some natural language processing methodologies to compute the similarity level, and the grading will be done based on the level of the similarity with the model answer. So it is not like that X is teaching the course and student P is giving the answer. Student's answer is taken as input, and model answers, aggregated model answer, maybe multiple model answer for the same questions will be there. So the system will compute automatically the similarities, percentage of similarities, level of similarities in terms of various processing methodology. I'm not going into details of that, but your answer is single sentence answer, and you compute the level of similarity and you give the rank. Now let us consider the multiple sentence answer. So this is some of our works. That means your answer is composed of multiple sentences. And again the same thing is done. You see that for this research we have, you see, one for operating system, subject, we have gone for 100 questions, and we have collected more than 3,000 answer, model answer from across the country. We have collected from various teachers of various engineering institutes and you have gone for some aggregated model answer. Then we have taken, I think, 100 or more students. They have given the examinations for 1 hour, and we have taken their answers, and we have computed the methods using our algorithm, and we have computed the similarities, and we have generated the grades, and which has been published very recently in some SCI journals of 5.5 impact factor. So what is the gist of this assessment? That means the automated assessment technique based on bag of words or verbs we are using for authentic assessment systems. So in your real world environment, so various assessment, I'm just skipping this, these are not very relevant. Yeah. Here you see that not only the assessment of a learner on a subject, we are also accessed and we are also analyzed the learning parameter of a learner based on the dataset using your AI and ML techniques. You see that we have dataset as collected, data are stored, and we have trained the model, we have applied the trained model, and we have used the XAI algorithm, and we have identified various learning parameter of a students, that which one is preferred by the students, what are the critical parameter, it is academic conditions, distance, or what are the matrices. So some data sets are available and we have used that. You see, these are the data sets outputs. You see that class duration, location, institution type, financial conditions, self LMS, internet type, network type. Out of that, you see class duration plays a major role. We have used XAI algorithm, FAMX, to design this output. So let us consider assessment of multiple sentences as a paragraph. You see, we can use the n-gram. What is n-gram? You see, we have a bigram, trigram. So you see that unigram is that you have taken. This is a sentence. In n-gram, this is a sentence. Then if you go to the bigram, so you see this is a sentence. Then in trigram, this is a sentence. So we have computed the similarity based on this methodology, n-gram methods, and we have generated the similarity index based on this n-gram techniques, and we have evaluated the learner for the multiple sentence in terms of the subjective assessment. And how we are grading? We are grading based on the extent of the similarity of the outcome of the learner. You see, these are, I think, yeah. So when I am talking about the model of assessment, what will be the component of model of assessment? This may be actor, question, answer bank, obtained response, question classification. Because in your Bloom's taxonomy, you have to provide the questions in all level. Then your evaluation module, and then report generation. So this will be some phases when you are going for assessment, analysis, and grading. But all are in terms of automated stage. So what is the conclusion? So this work achieve a comprehensive framework model for automated assessment and grading to evaluate the subjective type of answer, not the objective. And using the advanced state of art deep learning modules is not considered. We have used the general AI models and ML model, machine learning models. Here rubric system is not used till now. You can use for the rubric systems. These are some of the publications. This is last publications. You see that for the students learning parameters were published in last year 2023 for you see education and information technology, Springer, and some other publications. So this is in short, some list of other publications are there. So these are some indexing. So these are in short. This is my lecture. So over to you so that you can go for some question and answer.
So I request all the participants, if you have any question, please ask.
Yeah, please. Okay, now you just provide my mail. If any question anytime, they can ask
Okay.
through my email. That's no problem.
So, thank you,
Thank
sir,
you for
this
patience here.
session, and I hope you will be with us till 5 p.m. because the village session will be started at 4:30 and 4 to
4:30.
4:30.
Okay, no problem.
Okay, sir. Thank you, sir.
Thank you very much. So again, okay, I'm joining here. No problem.
Okay, sir.
Or I may join after some time. Okay.
Okay, it's your choice, sir. No problem.
Okay, I'm joining after some time so that I can do some work. Thank you very much.
Yes, sir.
Thank
Okay.
you. Bye. I'm
Bye,
joining
sir.
again.